So hi everyone, in this video we'll discuss the question maximum point you can obtain from a card. So it is the most important question till now. Okay, so what is given in the question? We are given the several cards arranged in a row. Okay, for each card there is a number associated with it. So we are given an array, and on each card there is a number written, and the points are given in the integer called card points. So these are card points. In one step you can take out one card from the beginning or from the end and have to take exactly k cards. So our number k should be given to us, so we have to take out k card from these deck, or we can say a array, and your score is the sum of the points. जो भी card तुम pick करोगे, the cards you pick from this array is the sum of उसका summation होगा. You will get the summation of the cards you have picked, the points you have on these cards, and you have to maximize the score. Okay, so this is the question that is given. So let me explain you the question in more detail. So you are given a card, or an array of cards, and on each card a card pointer is written. Okay, so these are the card point, and what you have to do, you have to pick k cards from this array. Let's suppose for this condition the k is 3. K is 3, so we have to pick 3 cards, and what we can do, we can pick the card from the beginning or from the end. Okay, in one step you can pick one card from the beginning or one from the end, and we have to pick exactly k cards. Okay, so for this question, if we pick one on, if we pick from the beginning or from the end, in both the condition our answer would be 1. So we have picked one time. Now we have two more cards to be picked. So which card we will pick, 2 or 1? So we'll pick 2. Okay, we'll pick 2, and then we have the choice to pick from this 3 and this one. We'll pick 3, so we'll have 6 as one of the possible answer. Now if we pick the card that is from the end, we'll have our answer as 1 plus 6 plus 5. Or there could be one more possible answer. Let When we pick 1 from here, 2 from here, what will be the possible answer? 1 plus 6 plus 1, that would be 8. One of the possible answers should be, if we pick 2 cards from here and 1 card from here, we have 1 plus 2 plus 1, that is 4. And one more possibility. So we have covered all the possibilities that are possible. So if we pick 3 cards from here, the answer would be 6. 2 cards from here, the answer would be 1 plus 2 plus the last card from the ending. Okay, if we pick one card from here, then we can pick 2 cards from here. We have 1, 6 plus 1, that is 8. And if we pick neither of the card from the beginning and all cards from the end, we will have 1 plus 6 plus 5, that is 12. So we have to return the maximum answer. So in this case the answer will be 12. So this is the particular question we have to solve. So one approach what we can do, so we are given the array. Let's suppose 1 2 3 4 5 6, no, yes, 6 and 1. So this is the array, and the number of cards we can pick is 3. So what we can do, firstly we pick all the cards from the beginning. So our answer would be 6 till current point. Okay, currently our answer will be 6. Now what we'll do, we'll remove this card and also the card point from our answer and add this card. Okay, so now our card would be these. So our answer would be now 4. Okay, if we now, if what we'll do, we remove this one also and add this one. So now we have our answer as, if we, and at every point when we remove a card, we check for the maximum answer. So at the first iteration, when we have all three cards, all these cards selected, these, the cards from the beginning, if we select k cards from the beginning, we'll store our answer in the temporary variable. So we have our answer as 6. We should maintain one more variable that contains the maximum sum that we can have by adding the cards point. Okay. So currently our answer would be 6. If we remove this card and add this card, our answer would be 4. Is it greater than the maximum? No, it is not. So we remove this card also and add this card. So uh, we have these cards, and the sum will be 1 plus 6 plus 1, that is 8. So the maximum answer would be updated as 8. Okay, so we'll remove this one also. Now we have these cards from the end. Now we have 1 plus 6 plus 5, it is equals to 12. So we are looking for a maximum answer, so our maximum answer will be updated and we'll get as 12. Okay, let me walk through one more test case and try to find the answer. We have, let's suppose we try for this. Okay, we have 9 7 7 9 7 7 9. Okay, and k value would be 7. Okay, now what we'll do, we find the summation. We find the summation of all the k cards from the beginning. We find its summation. So it would be 16 plus 16 plus 14 plus 9. So it would be 25 plus 32 and 7. So it would be 57. Okay. Now we have the summation of first k cards. Now what we'll do, we remove this card, and what we'll do, we add this card. So it will, if the k value is equals to the size of the array, now in this case the answer would be the summation of the all the elements of the array. Okay, so this is the first approach which we can implement to solve the question. So what we gonna do, let me write a pseudocode for it. Okay, firstly what we have to do, we find the summation of first k elements. Okay, first k elements, we find its summation. Now one by one we start removing the kth, k minus 1th element and start adding from the last. Okay, so if this was the k elements, then we'll remove this element and add this element. We remove this element and also add this element. So we'll have these and these in our sum. Okay, and we'll find all the possibilities that we have and return the maximum sum which we can obtain. Okay, so we'll run a loop from I equals to 1 to the value of k. Okay, if, now first of all what we'll do, we find the summation, then we'll check the condition as we find the cumulative sum. Okay, now if k is equals to n minus 1. Okay, k is equals to n, then what we'll do, if k is equals to n, then we'll return what, the summation of all the elements of the array. Okay, now if this condition does not satisfy, then one by one we'll run a loop, because we are removing elements, all the elements k times from the beginning and adding k times from the end. So we'll run the loop from 0 to k minus 1, then what we'll do, we'll remove this element and add the last element. That means we are removing from kth and adding the nth element. Okay, now what we'll do, we find our answer as summation. That what we have is our sum of the kth element. We'll do sum is equals to sum minus, then we have to subtract this element. So what we'll do, we'll subtract a of k minus I plus 1. So in zero based indexing, so if this is a k, that means the third element, we have to remove the second index element. Okay, and add n minus 1, that is the last element, minus I. Okay, and at each time, at each iteration, we'll calculate the maximum value. Okay, maximum value, and we'll return. Let us one more time analyze the test case, how this code will work. We'll have this test case 1, 2, 3, 4, 5, 6, and 1, and the value of k is given to us as 3. So we'll add first 3 elements. We have our answer as 6. Our variable that stores the maximum sum will have the answer as currently 6. Now what we'll do, we'll check if the value of k is equals to n, we'll return the answer, because that is the sum of all the elements of the array. Okay, if this condition does not match, then what we'll do, we'll remove this element, add this element. Now what will be the sum? The temporary sum will be 4. We compare it with maximum, no, it is not greater than the maximum. Then we'll remove this one, add this one. We have the sum as 8. Is it greater than maximum sum? Yes, it is. So we'll update our maximum sum to 8. Now we remove this one and add this one. So at this point, after completing this iteration, our loop will end. And for this, we have the answer, temporary sum answer as 12. We'll check if this temporary answer is greater than the maximum. Yes, it is. So our maximum sum will be updated to 12. So it is one of the possible approach to solve the problem, and it requires time complexity of order of 2k. Okay. At worst case, it requires time complexity of order of 2. In this case, complexity of order of 1. Okay. So the second approach which we can apply in the question is the modification of the sliding window. Okay. So how can we mold it into a sliding window question? So what we have to do, we have to find the summation of k elements that starts from the beginning or from the end. Okay. And their summation should be maximum. Now what we can do, if we look closely into this question, if we find the value minimum value of n minus k elements, then we of course have got the maximum value for k elements. Let that sink in. Okay, so what I'm trying to say, if we are in a mission to find the maximum value for the k elements that starts from the beginning or from the end. So what we can say, if we the possible conditions, let us draw the possible condition, then it would be more clear. So one of the possible conditions should be, we have this array and we have our sum as this. Okay, take a look at this array. Okay, at each condition, take a look at this array. Okay, one of the possible answers should be, if we have these two, and this one. Okay, we are left with these elements. Okay, now one of the possible conditions should be, if we have just this from the beginning, one element from the beginning and two elements from the end, we have 6 1, and these middle elements are excluded. Okay, then one of the possibility should be, if all the elements are selected from the end, we have 5 6 1, all the elements are selected from the end, then these elements are excluded. Now what we are going to do, we find the minimum value for these elements. So this forms a subarray. This forms a subarray of size n minus k. This forms a subarray of n minus k, and we have to find its minimum value of subarray elements of size n minus k. So it reduces, this quotient reduces to finding the minimum value of subarray of size n minus k, that will be easily solved using sliding window approach. Okay, so what we are intended to find, we'll find the value, minimum value of this, minimum value between this, minimum value between this, and which one of these we get as the minimum. We'll subtract the sum of all elements of the array from that. So in that condition we'll get the maximum sum for k elements. Okay, that starts from the beginning or from the end. So what I'm trying to say, we look at all the possibilities in which k elements should be selected. We can select k elements from the beginning. If we can select k minus 1 from the front and one element from the ending, we select k minus 2 from the beginning, we select 2 from the ending. So in this way we progressively move forward. Okay, and there will be a condition where we select 0 elements from the beginning and all elements from the end, and we are looking at the remaining part of the array and finding its maximum value. So the remaining part of the array will be a subarray of size n minus k, and we are finding its minimum value, because after finding the minimum value, after summation of all the elements and subtracting this minimum value, we can get the maximum value for the k elements that will be picked from the beginning or from the end. Okay, so this is the approach, and I will write the algorithm for this. First thing what we are doing, we are calculating the window size n minus k. Okay, what is n minus k? If n minus k is 0, that means our window size is of length of array size. So we'll directly return the sum of all array elements. Okay, sum of all array elements will return. Then what we'll do, our window size will be, let's suppose x, we have n minus k. Now for this x, for this window we'll find the minimum sum of the subarray of window x. We can easily find using sliding window approach by applying. I will write the code for the sliding window approach for this. Now what we'll do, after finding the minimum sum for this part, then we'll subtract this part sum from the total sum of the array. So we'll have ts as the total sum of the array elements. We'll subtract it from the minimum sum which we'll get for this window, and this would be our answer. Okay, so this is basically the question that will be reduced to minimum sum of subarray of size n minus k. Okay, So we have x is equals to n minus k. What we'll do, we'll take two pointers, I equals to 0, j equals to 0. Okay, we'll increase the value of j, that is j denotes window ending size and I denotes window starting size. So we'll have a loop till the window end reach the end of the array. So if the window size is denoted by j minus I plus 1, okay, if it is less than x, that is the window size which we are looking for, then what we'll do, we'll move to the next element. And at each iteration, the first step should be to find the summation of the array elements, temporary sum. So we'll find the sum, okay, and if we reach the window size, then what we have to do, we have to calculate our answer. So our mn here will contain our answer. Initial, it would previously be been initialized to infinity, that is int max, and we'll store the minimum value of mn and the window size, or what we can say, the summation. We have j here. Okay, so we don't have to calculate the window size, we have to just find the sum. Okay, so we have mn equals to min of mn and sum. Then what we'll do, we'll subtract the sum of the window starting, because we have to slide the window to the next element. We'll subtract it, and what will we do, we move this, the window start should be moved to the next position, and similarly the window end. And in this way we'll find our answer. At the end we'll return mn. So this approach will require us a time complexity of order of n, because we have to find the summation of the array. Okay, so here we don't have to return mn, sorry, we have to return mn, sorry, sum of the array element minus n. This is what we have to return. And to find out the summation of all the array elements, time complexity requires its order of n, and space complexity here is. So this is a question that is asked frequently in the interviews. So if you have any doubt, please feel free to ask, and I have the code given below in the description.